Hi everyone, today we'll look at what to do when an equation of a line is given to us in a form other than y equals mx plus b. Let's imagine we were given the equation 2y equals 4x minus 2. In a case like this, the y is not on its own, so the equation is not technically in the form y equals mx plus b. It's 2y equals something. So in this case, in order to get the y by itself, we'll need to divide by 2. So we'll divide every term in the equation by 2. This will give us y equals 2x minus 1. And now we can create a graph. We'll start at -1 on the y-axis because that's the y-intercept, and we will count up 2 for the rise and over 1 for the run. We can continue this count of up 2 over 1 until we run out of space on our grid. And then we can put a line through the points and put arrows on either end. In this case, we have 2y again, so y is being multiplied by 2, but we also have 8x being subtracted from that term. So in order for us to get y by itself and put the equation in y equals mx plus b, we will need to move the negative 8x to the other side of the equation, remembering that when a term crosses the equal sign, if it was a negative, it will become a positive. At this point, we can divide all terms by the 2, the coefficient of y, in order to get y by itself. This will leave us with y equals 4x minus 5. We can plot the minus 5 as the y-intercept, and then we can count up 4 and over 1 repeatedly until we run out of grid space. Then we can draw a line through our points and put arrows on either end. We'll use this idea of isolating the y or rearranging the equation into y equals mx plus b a couple more times. In this case, we're going to move the negative 4x across the equal sign, which will make it become positive. This will leave us with 6y equals 4x minus 12. Now we can divide all terms by 6, and this will leave us with y equals 2x over 3 minus 2. We can plot this on our graph by starting at the -2 as our y-intercept, and then counting up 2 over 3 repeatedly again until we run out of grid space. In this second part of the investigation, we want to pay particular attention to our intercepts, both our x and our y-intercept. We know our y-intercept is our b value in our y equals mx plus b, so in this case, our y-intercept is -2. From the graph, we can see that our x-intercept is 3. This is an important bit of information because we're going to need to learn how we could look at the equation to determine the x and the y-intercept instead of having to go to all the trouble of rearranging it and then plotting it on a graph. This will help us to take a little bit of a shortcut or to have an alternative method for how to graph a line in the future. Pause the video now and see if you can find the connection between the x and the y-intercepts and the equation as it was originally given to us. Based on your observations from the previous question, can you guess what the x and the y-intercepts will be for this one? The equation is -5x plus 3y equals -15. Let's graph the line to see if your predictions are correct. We'll begin by isolating the term 3y. We'll move the -5x across the equal sign and it will become a positive. We'll divide all terms by 3. And we'll simplify to y equals 5 over 3x minus 5. We'll plot this by beginning at the -5 for the y-intercept or the b value, and then counting up 5 and over 3. We'll only be able to do this once on this graph, so we'll draw a line through those 2 points and put arrows on either end. Now we can see that our x-intercept is 3, and our y-intercept is -5. Pause the video now and see if you can determine how the x and the y-intercepts of -5 and 3 are related to the original equation. Did you notice that when you divide the constant -15 by the coefficient of x, that you get the x-intercept of 3? And similarly, that if you divide the constant of -15 by the coefficient of the y term, that you then get -5. This is a shortcut for how we can find the x and the y-intercepts from an equation even without graphing. So there are 2 things that you can do when an equation is provided to you and it is not in the form y equals mx plus b. The first way is to rearrange the formula so that y is isolated. We've seen this done a few times so far. So we would get the y by itself by moving terms that have the x's or constants to the other side of the equal sign, and then we would divide by the coefficient of the y term. At this point, having the equation in y equals mx plus b form, it's quite straightforward to graph. We begin at the y-intercept, and then we count the rise and the run repeatedly until we run out of room, draw our line, put arrows on either ends, and then we have our graph of our line. Our second method involves using the equation to find the x and the y-intercepts. To do this, we need to recognize that all intercepts have something in common. They all have zeros in them. If it's an x-intercept, the y value will be 0, and if it's a y-intercept, the x value will be 0. So in order to find the x-intercept, all we need to do is sub 0 in for our y value. We will have 3x plus 2 times 0 equals 6. That 2 times 0 term will actually go away because we know anything times 0 is just 0. So this will leave us with 3x equals 6. And then we can divide both sides by 3, and this will leave us with an x-intercept of 2. So we know that the x-intercept will be 2, 0. To find a y-intercept, we do the opposite. We'll substitute 0 in for the x value. So we will have 3 times 0 plus 2y equals 6. The 3 times the 0 will again disappear because 3 times 0 will give us 0, and this will leave us with 2y equals 6. We'll divide both sides by 2, which will leave us with y equals 3. This is our y-intercept. Our y-intercept will be 0, 3. We can plot both the x and the y-intercept on the grid, and this will give us 2 points through which we can draw a line and put arrows on either end, and we will have our line graphed. So in either case, we can end up with our line graphed, whether we do it by rearranging in method 1 or by finding the intercepts in method 2. Ultimately, the way that you will graph a line that is not given to you in the form y equals mx plus b will be by preference. You might like to rearrange equations. You might also like to substitute zeros into the equations to find the intercept. The choice will be yours. As you do your practice today, try to consider using both methods. The method of finding the intercepts might not seem like a very intuitive method for you to use at this point, but it is something that will become very important in grade 10 when you learn about finding the x-intercepts of quadratics.